Hello, my Math 006ers. What we're looking at in this lesson is 7.5 complex rational expressions. We have two lessons this week, 7.5 and 7.6. So here we're starting with 7.5. First thing we need to talk about is what is a complex rational expression? Well, we're going to start with just the definition of a complex fraction. It's a rational expression that contains fractions in the numerator, denominator, or both. So more or less, the idea of a complex fraction is it's a fraction within another fraction. So if you see a fraction as a numerator or denominator, then you know it's what we call a complex fraction. So here's a little example we're going to work through first. The efficiency of a jack E is expressed by the given formula, where H is determined by the pitch of the jack's thread. Determine the efficiency of the jack if H is 2/3 without the use of a calculator. I mean, we want to work through this by hand just so we can get a sense of the process that we have to use when we are not dealing with just all numbers, when we have variables into the mix. So what we have to do here, we know H is equal to 2/3. So let's start. Okay, we know H is equal to 2/3. So we have this formula. E is equal to, and it's 1/2 of H, and so the operation there is multiplication, so 1/2 times 2/3, and we're dividing it by H, which is 2/3, plus 1/2. So you can see that this is definitely a complex fraction because we have fractions within the numerator and denominator. Now think way back to your early algebra days. Whenever you have to evaluate an expression of some sort or simplify an expression, you always want to simplify the numerator and denominator first, and then you can work through the problem as a whole. So what we want to do first is just really focus on simplifying the numerator. You can think of them in parentheses, and then the denominator. Again, you can think of it in parentheses. So in the numerator, let's see if we can squeeze it down here. 1/2 times 2/3. Multiply fractions, go straight across, so we get 2/6. We'll worry about reducing it in a second. Now the denominator, and I'm definitely running out of space, we have to add 2/3 plus 1/2. Well, in order to add two fractions, we have to find a common denominator there. And the common denominator would be 6, which means we need to multiply the first fraction by 2/2, which would give us 4/6. And we need to add it by, we have to multiply the 1/2 by a 3/3, which would be 3/6. Now I'm going to just draw a vertical line here. I'm going to come up here and work. So we still have that numerator of 2/6, but now we need to add our denominators, which would give us 7/6. Now, you can think of this as now we are dividing two fractions. This would be the same kind of problem as this. So sometimes it's easier to think of it as a horizontal problem, but we know in order to divide fractions, we multiply by the reciprocal of the divisor. So we take that 2/6 and we multiply by the reciprocal of the second one, which would be 6/7. Now it's easy to see what happens. We know our 6's will cancel and we're left with 2/7. So that's the process, if you will, that we're going to be taking with these problems. We're just going to have some variables into the mix as well. If you need to, pause the video, start it back over, watch through that again. Make sure you fully understand all those steps. If you don't, reach out to me, say, hey, where'd you get this? How'd you do that? Or whatever you need to do in that aspect. Okay, so there's going to be two methods we're going to be looking at when we need to multiply these complex expressions. So the first method we're going to be looking at here is going to be multiplying by the least common denominator. So this is going to be the first method we're going to be looking at, multiplying by the least common denominator. So what we want to do here is when we're looking at this first problem, we need to look at the denominators of everything. So within the numerator, we see, let's see if I can squeeze it, we have a denominator of 1, a denominator of 4. In the denominator, our denominators are 6 and 1. So out of a 1, 4, 6, and 1, we know that altogether here, the least common denominator, I'm going to just write this here, is going to be, with 6 and 4, it's going to be a 12. So what we need to do now is multiply, just like it says here, so I'm following these steps, find the least common denominator, we did that. Now multiply the complex rational expression by an expression equal to 1 written as least common denominator over least common denominator. So we are going to multiply this by 12 over 12. So now what we're going to be doing is we want to think of this as we need to multiply every single term in the numerator and denominator by that 12 there. So we want to bring my equal sign. So my first one, or you can think of it as distributing this 12 to both of these things. So we have 2 times 12 plus 3/4 times 12. And then we do the same thing in the denominator. We have 7/6 times 12 minus 3 times 12. Now we can go ahead and simplify. The first one, 2 times 12 would be 24 plus. Now when we have to simplify this one, we know 4 goes into 12 3 times, and then we do 3 times 3, which is 9. The last one, or the denominator, 6 goes into 12 2 times. We know 7 times 2 is 14. Minus 3 times 12, which is 36. Now we still need to continue simplifying the numerator and the denominator, but now we just need to add some numbers together. So in the numerator, we have 24 plus 9, which would be 33, divided by 14 minus 36, which would be a negative 22. And the last thing we have to do is simplify if possible, which when we look at this, we see that 11 is a factor of both of those. So when we simplify, we'd get a negative 3/2. And that would be our final answer for that one. Now looking at this next problem, we now have variables in the mix, but we're going to approach it the same way. So step 1, find the least common denominator. Now when we look at all of these denominators here, we have an A, a B, an A, and a B. So that means the least common denominator, going back a couple of sections, the least common denominator here, I'm going to write it above it just so I don't get it mixed up in my problem, is going to be a factor of A and a factor of B, because you need at least everything. So now we're going to multiply this whole thing by AB over AB, which is the second step of multiplying the complex fractional expression by an expression equal to 1. Now we have to simplify. And so now what we're doing is we need to distribute, just like we did before, the AB to every single term. So in the numerator, we have 1 over A, and we need to multiply that by AB. And we're adding it to 3 over B, and multiply that by AB. Now going to the denominator, we have 2 over A, multiply it by AB, and we're adding it to 1 over B times AB. Now we want to go through and actually multiply all of these. So 1 over A times AB. Well, we know that the A's will cancel, so we're left with 1 times B, which is just B. Plus, here we have the B's will cancel. 3 times A is 3A. Oops, that should be in blue, is 3A. In the denominator, the A's will cancel, so we're left with 2B plus, and then in the second one here, the B will cancel, and we're left with 1 times A is just an A. Now when we look at this, we see B plus 3A. We can't add those two together. And 2B plus A, we can't add that together. So this would just be our final answer here. You'll notice that this step right here and this step right here, what we're doing is clearing all of the fractions out of the numerator and the denominator. If you took Math 005, you would have remembered clearing fractions when we're solving equations. It's the same idea here. We're eliminating the complex fraction and just creating just a regular fraction that we're used to. So that's the first method, multiplying by the least common denominator. This section, so again, if you look here, you'll see that there is more than one fraction in the numerator and denominator. So if there's more than one fraction, or terms, if you will, in the numerator or denominator, you want to use this first method. To be the second step here is going to be dividing them out, or kind of what we did up in the top one when we looked at this step right here. We're just going to be jumping right to that. The method we're looking at is going to be just dividing it out. And you can see here that this tells us, let's go back to the little highlighter here. This tells us this is best when there is a single fraction on top and a single fraction on the bottom of the rational expression. Before, what we were looking at that there was more than one. But if there's only one fraction, like you see here, then this is going to be the easiest. And what we're going to do at this point is just pretty much go step. So this first one, we have 7/3 divided by 5/6. Again, we can write this. We want to multiply by the reciprocal of the divisor. So the divisor here is going to be this bottom one, so we want to invert the numerator and the denominator here. So we have 7/3 times 6/5. Now what we have to do is multiply straight across. But we'll also notice that we can simplify. So we can take that 6 in the numerator, and I'm actually going to erase that 6 and rewrite that as a factorization of 2 times 3. So I'm going to rewrite that as 2 times 3. The purpose now is I can see that these 3's will cancel. Now when I multiply straight across, I have 7 times 2, which is 14, divided by 5. And we leave it just like that. The next problem, again, we want to multiply by the reciprocal of the divisor. So multiply, and now just like we did in the previous problem, we want to invert the numerator and the denominator here. So we have 2x minus 8 over 3. Then you also notice that over in this one we just did, we took that 6 and changed it to 2 times 3. We factored the 6. We're going to do the same thing with this numerator, and we are going to factor it because that's going to help us cancel nicely. So I'm just going to rewrite the first fraction and then multiply it, and we notice that a 2 factors out, so we have 2 times x minus 4 over 3. Now we can start canceling. X minus 4, x minus 4. And then you multiply straight across. So the numerator, we have x times 2, which would just be 2x over 3. And that's all we can do with that one. Okay, the last 4 examples is going to be simplify using either method. So it doesn't matter which one you use here, you can choose whichever you want. This is going to be a point where, like if we were in class, I would have you work on your own. I'd kind of come around and help you as you needed it. So what I'm going to do here is we'll start with, I'll probably do 1 and 2, and then we'll do 3 and 4 separately. And I'm going to tell you to pause the video and try to work through these out using either method. And then I will resume the video and kind of go through my work with you. But when we look at these, you look at the first one. We'll notice that in this first one here, we have 1 fraction in the numerator and 1 fraction in the denominator. That tells us that the second method is probably going to be the easiest here. Whereas in number 2, you'll see that you have 2 terms in the numerator and 2 terms in the denominator. So here, it might be easiest to use the first method where we just find the least common denominator of everything. So let's just start with 1 and 2. So go ahead, pause the video. I want you to work through these problems and then resume the video and check your work. Okay, so here's my 2 answers. You can either pause it and look through it yourself, see if you can find your mistake, or you can listen as I kind of walk through these quickly. So the first one, and also something really cool, I found a really neat pointer here as I go through it. So I multiply by the reciprocal of the divisor. So I take my first fraction, 2x over 3y squared, and I multiply it by 6y over 5x squared. Again, that's just the reciprocal of the second one. Then what I did is I multiplied everything together. So I took the 2 times x times and then 6y, but instead of writing 6, I factored it into 2 times 3 times the y. And then I just really, I expanded everything here. So 3y squared would be 3 times y times 5x squared, which would be 5 times x. And then I used the yellow to start canceling things. So it's kind of hard to see, but you can see that I crossed a 3 here for a 3 here. And then I crossed an x for an x and a y for a y. And then left in the numerator was 2 times 2 is 4. And then y times 5 times x is 5xy. In the second one, I look at my denominators. I have a 1, a 3, an x, and a 2x. Well, out of the numerators alone, 1 and 3, the least common denominator there would be 3. Looking in the denominators, x and a 2x, the least common denominator there would be a 2x. They both have an x, so that's good. And then we have a 2x. So 2x times 3 would be 6x. That means that each of these denominators would go into 6x evenly. And again, the purpose of that is so we can clear our fractions. So we distribute the 6x to the 5, the x plus 3, the 4 over x, and the 1 minus 2x. And you can see that I did that there. And I multiplied. 5 times 6x is 30x. And then this one, the 3 goes into 6 two times, so x times 2x would be 2x squared. The x's cancel here, so 4 times 6 is 24. And then over here, 2x goes into 6x 3 times, or you can think 2 goes into 6 3 times, and the x's cancel. 1 times 3 is 3, so 24 minus 3. The numerator does factor, so I did factor it to get 2x times 15 plus x. 24 minus 3 is 21. Nothing cancels here, so we can just leave it as it is. Again, if you have any questions, let me know. Go back, re-listen to that, or see if you can find your mistake. If you do have questions, do a screenshot and say, hey, where did you get this at? Now, I want you to go ahead and look at 3 and 4. 3, again, with 3, you'll notice that you have one fraction in the numerator and one fraction in the denominator. So the second method might be easiest, but it's also pretty easy if you use the first method too because of something in particular. Number 4, you'll see that you have 2 fractions in the numerator, 2 in the denominator, so the first method is probably going to be easiest. Again, pause your video, work through these problems. Okay, so I have my pointer back here. So the first one, I multiply by the reciprocal of the divisor, and you notice that the x's cancel right away. And then I factored the denominator, canceled out my common factors, and then got 1 over x minus 1. Here you could have very easily multiplied by the least common denominator, which would be x over x, and all your x's would cancel, and you'd be left with this x plus 1 over x squared minus 1. So that method would have worked easily as well. The next one, we look at our denominators, x squared, x, and x cubed. So the least common denominator is going to be x cubed because that's going to be, if you will, the most factors of the x. So we multiply everything by an x cubed and simplify, clear our fractions, and we get this right here. And then what we have to do is factor this. The numerator both have factors of a 7x. The denominator is a difference of squares. So when that factors, we get this 7x, and that's an x minus 2 over x plus 2x minus 2. Cancel your common factors. You're left with 7x over x plus 2. Hope this video helps. And I believe, was there, wait, there's more. Here, I thought we were finished. 5 and 6, I'll let you work through those. I'll fill the answers in and show those back up. But let's actually just at least read through 7 and I'll let you try that one too. Light bulbs are often wired so that electricity can flow through more than one light bulb. In this way, if one light bulb burns out, the other still works, unlike old Christmas lights. If 2 bulbs have resistance T and S, their combined resistance R is R equals 1 over T plus 1 over S. Simplify the formula so it is not a complex rational formula, meaning simplify it so you only have one, you don't have any fractions within the fraction, meaning we need to eliminate this fraction and this fraction. So I want you to try this one out. Think of that numerator, it's just a 1. Think of it as 1 over 1 if you need to. You can here find the least common denominator, which would be TS, multiply everything by that. Go ahead and work through that to see if you can simplify it so you don't have any fractions as a numerator or denominator. And go ahead and work through 5 and 6, and I'll work through those and then I'll show the answers. Okay, looking at our 3 answers here. For number 5, you should get 3x minus 1 over x minus 2. For number 6, you should get 2x over 5x minus 6. And for this last one, you should get TS over S plus T. If you need to, pause the video. I'm not going to walk through all of these. You can go back and follow my work. Probably the most difficult part of these in 5 and 6 anyway, we're finding the least common denominators. If you're still having difficulty on that, make sure you go back to section, I think it was 7.3, and look at how to find least common denominators. If you're still having difficulty, please reach out and I can try to help you out in a different method. I know this video was a little bit longer, but please let me know whatever you have questions on. Good luck on the homework. Bye.